And a final set of examples for these integration by part problems. Let's take a look at this problem. What we want to make sure is that this is not a u substitution problem. You could check, well, u might be x plus 6, right? Or maybe it's the square root of x plus 6. That's a worse guess. You'd want to guess x plus 6. But the problem is if you do that, this x will not go away. So that tells us we need to use integration by parts. So how do we do that? Well, we want to pick a u that gets easier to work with, and before I even do this, I'm going to do what I did before. I have something on the bottom, I want to put it on the top, so rather than divided by the square root of x plus 6, I write x plus 6 to the negative 1/2. Right? So I want to pick a u that gets easier to work with as I take derivatives. I could pick this, or I could pick this. I'm going to go with the x, right? X definitely gets easier to work with as I take derivatives. That means my v prime is going to be x plus 6 to the negative 1/2. Now, this is going to be a little bit tricky. So my u prime is going to be pretty easy to find, right? That's 1. But what about v? How do I take the derivative of x plus 6 to the 1/2? So I'm going to make a sidebar here because this is actually kind of a problem in its own, right? So let's write, we want to take the integral of x plus 6 to the negative 1/2 dx. So how do we do that? Well, we actually have to do a u substitution problem, or a w substitution problem, whatever you want to call it. So I'm going to do, this is a substitution problem, and I'm going to make w equal to x plus 6, and that means dw over dx is going to be equal to 1, which tells me that dx is equal to dw. So these are the two facts that I can substitute from. And so the way this will work is I'll have the integral of w to the negative 1/2 dw. And so that will be equal to, I can just use a formula here. Remember, I just add 1. So rather than w to the negative 1/2, I'll have w to the 1/2 divided by 1/2 plus c, which is really equal to 2w to the 1/2 plus c. To get that, you can multiply the top and the bottom of this fraction by 2 over 1. And resubstituting back in our x's, we'll get 2x plus 6 to the 1/2 plus c. So that is my v over here. This 2 times x plus 6 to the 1/2. Okay, so the trickiest part of this problem is realizing that we actually can take the integral of this b prime. To kind of be able to do this, we have to be confident in our u pick, right? This v prime pick is a little bit annoying to deal with, but it works out, right? So this integral here, I'm going to fill in my u and my v for the first. So we'll have x times 2x plus 6 to the 1/2. And then that's going to be minus the integral of v. So I still have this annoying v to deal with, 2 times x plus 6 to the 1/2. But now instead of an x in my integral next to my square root, I'll have this u prime, which is a lot easier to deal with, right? So I'll have the dx there, and so my final integral would be, or my new integral, rather. So I started with x times x plus 6 to the negative 1/2 dx, and now I have something that's not under an integral minus a slightly easier integral to do, right? 2 integral of x plus 6 to the 1/2 dx. Now, to do this integral, I am just going to do another little, I'm going to insert another page, and I'm going to do a little sidebar. So I have the integral of x plus 6 to the 1/2. I want to know what this thing is. It's going to be very similar to what I did before. So I'll have the integral of x plus 6 to the 1/2 dx. I'm going to need to do a substitution here. So I'll have w equals x plus 6, and then I'll have dw over dx equals 1, which tells me that dx is equal to dw. I'll make my substitutions, and then I'll get the integral of w to the 1/2 dw. So this is going to be equal to w to the 3/2 divided by 3/2. Now I'm multiplying the top and the bottom by 2/3. Gives me that this is really 2/3 w to the 3/2 plus c. And so substituting back in my x's will give me 2/3 times x plus 6 to the 3/2 plus c. Okay, so I know this is getting kind of a little bit tricky, but let's kind of reorient ourselves. So I started with this tough integral. I got a slightly easier integral to work with. This slightly easier integral is right here. This is basically what should be going in my box. And so I'm going to kind of start up again, right? So this hard integral, the first part stays the same. I have 2x times x plus 6 to the 1/2. And then that's going to be minus 2 times what was in my box, right? So 2 times 2/3 x plus 6 to the 3/2. And then this whole thing is plus c. The plus c always just gets tacked on at the end. So my final answer here is going to be 2x x plus 6 to the 1/2 minus 4/3 x plus 6 to the 3/2, and that's all plus c. The important lesson here is that you want to pick a u that gets easier to work with as you take derivatives, and sometimes the thing you need to take the integral of, it will take a little bit of work, like it did right here, right? We needed to use a substitution problem. But as long as you get an easier integral to work with than you started with, you're in good shape. That's kind of the lesson of this problem.